Hello and welcome. If you're looking to perform large-scale data migrations using AWS DataSync, this video will show you how to significantly improve your transfer performance by maximizing the usage of the available network bandwidth and to achieve higher data throughput using DataSync Scaleout architectures. I am Santhosh Arunuri and I'm a Specialist Solutions Architect at AWS. I'll start by introducing AWS DataSync, discuss building blocks of a DataSync data transfer process, provide an overview of scale-out methods, and also share some best practices to consider prior to starting a large migration project. AWS DataSync is a secure data transfer service that makes it easy to move file and object data between on-premises storage, other public clouds, and AWS storage, as well as between AWS storage services. DataSync is a fully managed service and enables fast data transfers as it uses a custom network protocol that maximizes the available network bandwidth. DataSync provides easy management of data movement workloads with inbuilt features like bandwidth throttling, migration scheduling, and task filtering. DataSync ensures security of data transfers and encrypts data in flight using TLS 1.3. It also provides data and metadata validations. The basic building block of AWS DataSync is a task. A task consists of source and destination locations, as well as various options that define the data transfer. Tasks can transfer an entire dataset from the source location, or a task can be configured with include-exclude filters to only transfer essential data. I'll touch on the include-exclude filters in the later part of this video. DataSync provides two different task operating modes: Basic and Enhanced. Basic mode tasks allow transfer of files or objects between supported DataSync locations and AWS storage like S3, any of the FSx file systems, and EFS. Basic mode tasks are subject to quotas on the number of files, objects, and directories in a dataset. Enhanced mode, on the other hand, provides the ability to transfer nearly unlimited files in a single task and has improved performance, particularly with large object datasets. The key difference to note between the two task modes is Enhanced mode removes the limits on the number of files per task and offers higher performance due to its parallel operations. It offers improved metrics and reporting capabilities to track and manage large data transfers. DataSync supports agent-based and agentless transfers when transferring data between supported locations and AWS storage. Whether you need an agent depends on several factors, including the type of storage you're transferring to or from, if you're transferring across AWS accounts, and which AWS regions you're transferring between. For example, when moving data from on-premises locations to Amazon S3, DataSync utilizes an agent that is deployed as a virtual machine, and the agent connects to your local storage system. You can also have an agentless transfer experience if you're using Enhanced mode to transfer data between other clouds and S3 buckets, between Azure Blob and Amazon S3, and for transfers between S3 locations. DataSync agents, locations, and tasks are the building blocks for data transfers using DataSync. The DataSync scale-out methods that I'll discuss in this video will be applicable to both agent-based and agentless transfers. A common DataSync architecture to use for a migration is to start with a single DataSync task. You configure a source location and a destination location for a task and associate a single agent to be used for the transfers. The performance of a DataSync task is dependent on numerous factors such as the available network bandwidth, performance of the source and destination storage, as well as the average file size. For smaller migrations, a single task may be all that is required to complete an entire migration. Now, let's consider a scenario of a large data migration project that involves moving terabytes or petabytes of data and millions or even billions of tiny files. In this scenario, DataSync architectures with one task and one agent may not be suitable. So, DataSync supports scale-out architectures for such migrations. Let's dive in. For large datasets, the first recommended approach to scale the data transfer is by using a multitask and multi-agent architecture. In this approach, you might use multiple DataSync tasks and agents to transfer data from the same source storage location. Each task is configured to read from a specific folder in the source location. Running multiple tasks in parallel using this architecture enables you to speed up the data transfers. Parallel tasks increase bandwidth consumption on your network, and running tasks simultaneously increase the I/O operations on both the source and destination storage. So, while using this approach, it is recommended to ensure your source and destination have the required performance to handle parallel task executions for successful migration. You can start with the approach of running multiple tasks by partitioning your dataset. Partitioning allows you to control which files to transfer using DataSync. Partitioning can be done in a few ways. When creating your DataSync source location, you can specify a folder, directory, or a prefix that DataSync reads from. For example, if you're migrating a file share with top-level directories, you can create multiple locations that specify a different directory path. You can use DataSync task filtering to include or exclude specific data from your source location. During the task creation, you can set include filters to specify the set of files, folders, or objects that should be transferred, and those that should be excluded from the transfer using the exclude filter option. Filters can help you scope the tasks to specific portions of your dataset. You can also partition your dataset using manifests. A manifest is a feature that enables you to provide a definitive list of source files or objects to be transferred by your DataSync tasks in a CSV formatted file. Partitioning your source data across multiple tasks and possibly agents lets you parallelize your transfers and reduces the migration timeline. Partitioning also helps you stay within DataSync quotas and simplifies the monitoring and debugging of your tasks. The second approach to scaling performance is to use multiple DataSync agents for a single task. This approach is recommended if the source data cannot be partitioned into folders and the dataset consists of millions of small files. In this case, you can configure a source location to use multiple agents per task. This approach provides additional parallelization that can result in increased file throughput. Lastly, for transfers at large scale, you can also mix and match DataSync multiple agent and task methodologies that I discussed. You can configure multiple tasks to run in parallel, specifying multiple agents as part of each task's location. All of the DataSync scale-out methods I discussed can apply to transfers from on-premises between AWS storage services or from other public clouds to AWS. I'd like to finally leave you with some common best practices when using DataSync to migrate data from a supported source location to AWS. Understand your source storage performance and baseline your source storage IOPS and throughput capabilities to set realistic transfer expectations and to identify bottlenecks. If your migration requires the installation of an agent, deploy the agent on the same network segment as your source data to minimize any latency. Size your DataSync agent with adequate CPU, memory, and network resources based on your data volume and transfer requirements. Your available network bandwidth factors into your transfer speeds and overall migration time. So plan migrations using available network bandwidth. Calculate realistic transfer times accounting for network capacity, any business hour restrictions, and overhead to set proper expectations. Always perform a proof of concept before starting full transfer. Execute small-scale transfers first to validate configuration, identify issues, and optimize any settings before committing to large production migrations. Know that file size affects throughput. DataSync tasks achieve higher data throughput when transferring larger files and can effectively utilize a 10 Gbps network link for large file transfers, whereas DataSync tasks that are transferring small files in the kilobyte range provide higher file throughput. Based on the file size of your data transfer workload, you will need to leverage different optimization strategies. Lastly, scale out performance with multiple tasks and with multiple agents to overcome single agent throughput limitations and to reduce total transfer time. To summarize, in this video I've discussed DataSync building blocks and various methods to scale out DataSync transfers using multiple agents and multiple tasks. Leveraging the scale-out approaches enables you to maximize the usage of your available network bandwidth while achieving higher data throughput, reducing overall migration timelines. Thank you for watching this video, and thank you for using AWS.